Hello, welcome to today's video. Here I'm going to show you how to calculate the area of a region bounded by a function that is negative for some of the values over the interval and positive for others, and also that requires u substitution when integrating it. So here I've drawn the graph of f of x equals x times the square root of 25 minus x squared. So I'll outline it here. The x-axis, x equal -4, that vertical line, and x equal 3, the vertical line there. Now if you notice from the picture, over the interval from an x value of -4 to an x value of 3, the region caught between those graphs is below the x-axis. So the definite integral there will come out negative, and we'll need to take the negative of that negative number to get our positive value that will represent area. Over the interval from 0 to 3, the region is above the x-axis. So there the definite integral will be the same as the area. Now let's look then at our first definite integral from -4 to 0 of our x times the square root of 25 minus x squared dx. Here we look at the expression 25 minus x squared is being acted on by the square root, so that's what we will let our u represent, that expression 25 minus x squared. Now we want to take the differential. The differential is du is equal to, and the derivative of 25 minus x squared is, well, the derivative of 25 is 0, the derivative of negative x squared is a negative 2x, and then our differential dx. Now notice here we have our expression 25 minus x squared is the u, and then as far as the x and the dx, that is part of our differential. However, that factor of -2 isn't in the integrand. So since it's a constant factor, I can divide that over to the other side and have -1/2 du will be the replacement for that x dx expression as we go. So now when we look at this, we also need to see that it's a definite integral. So we need to find out our replacements for our limits of integration. For the lower limit, when x is equal to -4, we'll get our u value is equal to, we'll look at what you let u represent, 25 minus x squared. So it's 25 minus that -4 squared, and that gives me 25 minus 16, or u is equal to 9. When x is equal to 0 for the upper limit of integration, our u comes out to be 25 minus 0 squared, which is 25. So this gives us the integral from replacing the -4x value with the 9u value to replacing the 0x value to a 25 for my u. Then I have the square root of 25 minus x squared's replacement is u, and then the x dx replacement is a -1/2 du. Now factor out the -1/2, numerical factor, and rewrite the radical as a fractional exponent. So I have the -1/2 times the integral from 9 to 25 of u to the 1/2 du. Now as we're integrating that, we notice that it's a letter base to a number exponent, and the number exponent is not -1. So we will use the power rule. Keep the letter base u, add 1 to the exponent, 1/2 plus 1 is 3/2. Divide by 3/2, which is multiplying by 2/3. And we are going to evaluate that from 9 to 25. Common factors of 2's remove. I have a -1/3 times 25 to the 3/2 minus a negative 1/3 times 9 to the 3/2. Now remember, when you're working with fractional exponents, the denominator of the fractional exponent is the root and the numerator is the exponent. So we'll think the denominator of my fractional exponent is 2, so that's square root. Square root of 25 is 5, and 5 cubed is 125. So negative 1/3 times 125 is a negative 125 thirds. And then I have minus a negative or plus. Square root of 9 is 3. 3 cubed is 27. So I have 27 thirds. And I know that simplifies, but I want to add these fractions, so we need to have those common denominators. Negative 125 thirds plus 27 thirds is a negative 98 thirds. It came out to be a negative definite integral like we anticipated. So remember, when we go to get the total area, we're actually going to use the opposite of negative 98 thirds, or 98 thirds, in with our area work. Okay, now let's look at the interval from 0 to 3. On our interval from 0 to 3, the substitution work that we did in integrating is going to be the same. It's just our limits of integration that we're going to need to work on. So remember, this is the integral from 0 to 3 of our x times the square root of 25 minus x squared dx. Our u substitution, our du differential, and dividing the negative 1/2 over is all going to be the same. But for our limits of integration, a lower limit of integration of x equals 0, well, that's going to be u equal to my 25 minus 0 squared, or 25. And for the x value of 3, u will be 25 minus 3 squared. That's 25 minus 9, which is 16. So here I have the integral from 0's x value goes to a u value of 25, and 3's x value goes to a u value of 16. And then I have the square root of u times that negative 1/2 du. And then integrating that, remember, we're going to pull out the negative 1/2, have that as u to the 1/2 power, and we're going to add 1 to the exponent, divide by that like before, and you've got negative 1/3 u to the 3/2, evaluated from 25 to 16. Plug in the upper limit of integration. I have 1/3 times 16 to the 3/2 power minus then a negative 1/3 times 25 to the 3/2 power, and that gives me, well, the square root of 16 is 4, 4 cubed is 64. I have negative 64 thirds plus, and then the square root of 25 is 5, 5 cubed is 125. So that gives me 125 thirds. And then my negative 64 thirds plus 125 thirds gives me 61 thirds. So then my total area is positive 98 thirds plus the 61 thirds, which gives me 159 thirds, which simplifies to 53 square units. And that gives our total area of the regions bounded by the function f of x equals x times the square root of 25 minus x squared, the x-axis, x equal negative 4, and x equal 3.